Sorry, I fell asleep at the wheel there. We're a couple minutes late. But again, I say good afternoon. Come on, guys, come on. Really? Good afternoon. There you go. Wake up. Everybody wake up. Next Tuesday, August 2nd, it will be August already. Even hotter. Coffee house music session with our friend Robert Gaudio, the Troubadour. And this Thursday, Dinosaurs Class 2, the Dinosaur Family Tree, with our friend Lindsay. She'll be back on the 28th at 7 p.m. Yay. And then on Tuesday, August 9th, Tom Breedhoft has a very unusual book called Foot. I won't tell you what it's about, but it's a mystery novel at WVU Press, and he'll be here on the 9th of August. Our guest today is Cory Campanizzi. He has a BA in, oh, by the way, turn off your cell phones. It's a good opportunity to do that. Thank you. Cory has a BA in psychology from the University of Ottawa. And it wasn't Lindsay going to Ottawa, didn't I say? Yeah, I think so, somewhere in Canada, but I think it was Ottawa. And MA in environmental studies from the University of Illinois-Springfield. His research and presentation areas include renewable energy technology, sustainable development and policy, appropriate sustainable energy technology, ASET, device building, psychology of sustainability, and electric vehicle conversions of antique European automobiles. Interesting. Here is Cory Campanizzi.
Hello, everyone. I may need to adjust this a little bit. Can you hear me pretty well without? You need a microphone. You good? You need a microphone? Okay. I wanted to ask to be sure. There we go.
We're the senior guys.
I just wanted to be, I wanted to be congenial. I don't want to, I'm just going to go ahead and use it now. Well, yeah, we're here to talk about electric vehicles, as you can imagine. And I wanted to title the presentation, Driving the Electric Vehicle Future. What is driving that change? Sometimes it's reluctant to be changed. I mean, I'm sure some people in the audience have questions about why we need to change. What's the difference going to make? So what's driving that? I think most people know that without going into depth. We're talking about, at least the IAPCC is talking about not going above 1.5 degrees Celsius in global temperature. And one of the major contributors to that, not the only, is transportation. So we're talking about transportation today. We're talking about electric vehicles. So we're going to focus on, that's the driving part, but what is it like also at the end of the presentation? What is it like to drive an electric vehicle? Day to day, practical. Does it work? Can it work for you? Those are things that you can come to conclusion on yourself. But it's important to have the facts as we see them right now, and also to look at some of the misinformation or disinformation that might be out there and clear that up and truly be honest and say, what are the things we still need to work on? So get rid of the low-hanging fruit of disinformation, the easy things, which we'll talk about. But where are the problems still at in the pipeline? That's the honesty I'm trying to convey today, okay? So we're going to talk about design, infrastructure, as the title says, sustainability, especially in the environmental justice arena. What's it like to be environmentally justice to the people who we may be needing or be needing these minerals from, where they live? We'll go into that. Advanced manufacturing in the state of between West Virginia and Ohio, which was now becoming, which we'll talk about, Voltage Valley. So reintroducing advanced manufacturing within the Ohio Valley, which I think most of us agree upon would be a benefit. We've lost a lot of our steel industry for various reasons, as we know. Let's face it, automobiles, what we're talking about today, or transportation, they don't need the same type of metal they used to. There's a lot of plastics, composite material that are now built into that. And let's hope this will advance for me. So the petroleum dominance in transportation, I don't think any of us need to ponder this too much, but if you look at the EIA, they're currently looking at 2021 records, and 90% of the total US transportation sector is petroleum. It's a large amount. So 90% of our transportation fuel comes from petroleum. And I think we can all attest to what's happened. You can leave politics aside, or you can inject it if you want to, what has happened in the last few months with gas prices. It's skyrocketed. And anybody who either drives an electric vehicle like I do or do not, I'm still affected by high gas prices also, because the remainder of the economy uses petroleum, as it's shown here, 90%. So of that pie chart that you can see there, and I'm sorry if the clarity is not real strong, but we're looking at gasoline is 54% of the petroleum we use as far as transportation. And I won't break down the individuals like jet fuel, biofuels, but natural gas is also included in it, because natural gas is a petroleum-based product. Now, when we look at transportation and break it down even further, how about transportation energy by mode and type? As we know in America, we love our light duty trucks, don't we? We like especially our 1-ton trucks and below, 3/4 and half-ton trucks. Those are a major part, of our economy, how we build out our economy. And let's be honest, some people don't need trucks that large. It may be more of a personal preference that they like, but there are places for light duty trucks to be involved in our economy. But right below the light trucks, which is at 30%, cars and motorcycles make up 23%. So those are two dominant transportation modes that use a majority of that 90% of the petroleum. And you can see broken down other trucks, which are larger, freight trucks, aircrafts, boats and ships, trains, military, pipeline, and then lubricants at the very bottom. So that's how it's broken down, how we break down our individual use of petroleum. Now, electricity generation by its source. I think the next few slides may or may not be convincing to you about making the shift to electric vehicles, but maybe not. Maybe so, maybe not. So electric generation by source in the US, what we see renewables stand at about 20% of the entire makeup. And that is quickly advancing, it's going higher. Petroleum is that small sliver, which is about 0.5%. Nuclear is at 19, coal was 22. It was once dominant, as you know. Coal was a major contributor to our energy economy. And natural gas now is not starting to take that void. So natural gas is now 38% of our overall electricity generation in this country. This is where we start talking about subsidies, something that often comes up. How do we subsidize our petroleum industry? The government has a heavy hand in this, regardless if it's renewable energy, which some people are adamantly against or question, and some people who are adamantly against fossil fuels continue to garner or continue to use subsidies, government subsidies. Fossil fuels once rose above renewables, as you can imagine. It now sits at 25%. So we are still subsidizing the fossil fuel industry. Renewable energy now takes up 59% of that. So you can see that market shift or that market focus change. And then we have what are known as direct subsidies and indirect subsidies. So one calculation I don't have on here, but it's easily available to anybody. If we are currently looking at the fuel prices right now, what we pay at the pump, without government subsidies for petroleum, we would be looking at per gallon cost about $12 or $13. Without our individual taxpayer contributions going to that. Forcibly, some people think that taxes are taken away from it. So we heavily subsidize even the petroleum industry still, including renewables. So renewables are part of that package. So when you hear people say, yeah, I don't want my money going to electric vehicles. Well, where is the market balance for people who have to pay taxes on petroleum industry? It works both ways. We're all paying some type of subsidy to provide R&D development costs, reduce that. The government funds that through taxation. We're looking at renewable energy through tax credits that we see people buy electric vehicles with a certain amount of tax credit. That's a part of the subsidy. So those are indirect and direct subsidies that we still pay out. If you look also, those are the actual tax codes I provided for you to show direct and indirect subsidies that are still on the IRS tax code for how we still support and maintain petroleum. Now, this is where I start to break away and try to show the advantages between electric vehicles and internal combustion vehicles, or ICE, as they're sometimes called. There's a great book, and you're welcome to look at it here when I'm done, but it's the cover of it's right on the front there, upper left-hand corner, turning oil into salt. What does turning oil into salt mean? It sounds kind of ridiculous, doesn't it, when you first look at that? But turning oil into salt identifies at one time salt was a valuable commodity to just about every society on earth. We fought wars over salt. So you can start to see the parallels between salt and petroleum. We fought wars over petroleum. So it's what's been deemed in economic terms as a valuable commodity or a controlled interest energy source, and it's very tangible to wars, country development. All those things are part of that. As you can imagine, when you have 90% of your transportation being supported by petroleum, you leave out any other conditions for change. Your portfolio is very narrow, but by which you can move your society forward through transportation. If you look at electricity, though, I think anybody knows in here, that electricity can be produced through wind energy, solar, as we show, tidal, hydroelectric, biogas, nuclear, and the legacy pieces like coal, oil, natural gas. It has a wide portfolio of what can be used to produce electricity. So when you introduce electricity into transportation, you now have the ability to have vehicles that are powered by multiple energy sources. That makes sense? Petroleum only comes from one avenue of fossil fuels. But when you produce electricity, you can come from a plethora, not only renewables, but in transition, what we see oil, gas, and oil, gas, and coal. Those are still available to us of that energy mix. So what does an electric vehicle look like as far as energy storage type? Well, currently we're using essentially 20th century technology, aren't we? We've had batteries with us for a long time, but they've changed. They've been lead acid, there have been nickel cadmium, there's lithium ion, there's sodium sulfur. There are different mixes that engineers have used over time to store energy, capture from whatever source it may be coming from. Coal-fired power plants, renewables, they all have to be stored in some type of form to make it transportable. So storage of electricity happens between an anode, I'm not going to get too technical with this, but an anode and cathode. Those things still hold true. So current material technology is lithium ion. That's the big buzzword, lithium ion is coming about. Past materials have been, like we talked about, nickel, cadmium, and lead acid. But the component makeup of the average at time vehicle battery is about 5 to 7% lithium, 5 to 20% cobalt, and 5 to 10% nickel. So if you look at the diagram, you can see it's broken down, and I won't go into too much detail about this because it's kind of self-explanatory. But you can see the charging point locations. This happens to be a Tesla Model 3, so the motors are in the rear as a part of the traction package. You have the high voltage battery that is currently laying underneath the belly of the vehicle. And then you have an internal cabin heater that provides heat to the occupants inside the vehicle. And you still have an air conditioning compressor that provides the opposite effect of cooling in the summertime. So all those are part of the modern electric vehicle. That wasn't always true. We've had electric vehicles for a while, but when you really get into the mass production of electric vehicles, which really have only been involved in about the last 12 to 13 years of full electric, you'll see that those modern amenities that we all like, heat, imagine that, air conditioning, they're all encompassed in a standard traditional automobile form. Outside of electric or BEVs, battery electric vehicles, we also have hydrogen fuel cells. The company that's really advanced this so far has been Toyota. They actually have a production hydrogen vehicle that you can purchase. As you can imagine, and the argument still stands pretty strong, we don't have the infrastructure yet for a large-scale hydrogen push-out. That makes sense? So if you go onto the government's website, or if you go onto any third-party supplier to see where that hydrogen comes from and where they're actually fueling stations, you'll find that the majority of them are in the West Coast because hydrogen is in a development stage. I would encourage anyone, though, that has a strong interest in hydrogen vehicles is to look into Toyota Miura. There's actually some great production videos where you can actually see the hydrogen fuel cell vehicles being built on the assembly line. And when you look at that, you would swear that you're in a hospital. It is that clinically driven. It's super clean. A lot of the byproducts, a lot of the waste is all recycled, or high percentage of it is, and it's amazing to watch that procedure go on. As you can imagine, most of that production goes on in Japan, in the Asian subset, but it's very interesting to watch if you want to see how a hydrogen fuel cell vehicle is produced. There's also what are called supercapacitors and ultracapacitors. They store energy in a solid state instead of a liquid, like the liquid lithium ion that we're talking about. It allows for better discharge and recharge times, but the density is lacking, and there's a drawback to it. So it's difficult to run a supercapacitor or ultracapacitor vehicle for any length of time. So what their best capacity is a boost. Let's say you're starting from a dead stop, and an ultracapacitor where you're trying to pass someone, that's where an ultracapacitor could store that energy and release it quickly to give it to the electric motor. It's the sprinter, not the long distance kind of capacity, if that makes sense. So what's the drivetrain look like? What's the layout look like in a modern electric vehicle? Right now, there's two currently developed. One, you have kind of a traditional transverse mounted front wheel drive, like most of us drive here today. If you drive a front wheel drive vehicle, it sits transverse in the engine compartment with an electric motor, a charger on board, and an inverter, and then you have what's called a gear reduction box. So there's no transmission to the modern electric vehicle yet. That may change in time. But you have a simple reduction gear. So the electric motor provides its energy in a simple form of putting an output shaft. And there's just a reduction gear that goes to your front drive axles, to your front wheels. So it's almost like driving an automatic. It has the feel of driving an automatic. But what you do miss are the shifts that happen in between. So an automatic transmission or manual transmission vehicle, you know that shifting feel. That's completely gone. It's a complete power band from stop to high end. It's just one continuous band of power. It's a different feeling. You don't feel those shift points. Now, if you look to the right, that's a Tesla Model S. The one I just described is the vehicle that I drive. It's a Nissan Leaf. And other manufacturers use this because there's less retooling involved. If you're working inside a factory and you're using a new form of propulsion with electric motors, you don't have to change your configuration that much from an existing front-wheel drive vehicle. You can have that layout be pretty much the same. You just lose the internal combustion engine. Now, the Tesla Model S, which you see there, they use induction motors. And you've probably seen maybe on the rear of a Tesla, it'll say dual motor. That's just what it means. It has two motors, and the motors are actually facing each other nose to nose, and they drive that reduction gear that you find on the left-hand side the same way. So when they have dual motors, that gives you the power of dual motors, giving that vehicle rear propulsion forward. So how many of you here have heard about a Tesla Model S Plaid? You probably have. Can you give us some insight about what you know about that vehicle?
Well, the Plaid is, well, the remotes may be but it's the fastest production car in the world.
Yes. So you know the official times? I won't give it away if you know.
2.34.
Right, and it's actually higher than that now. And what we're finding out, I'm an old gearhead. I've worked on internal combustion engines since I was about 13 or 14 years old, working in the automotive aftermarket. So I've seen the changes myself. So I'm not just new here to say, hey, I'm new to the stage. We're talking about electric now. I know where we came from. And we're starting to see people who are now not necessarily doing gear changing or modifying that way. They're actually doing software changes. So that whole dynamic, that whole language now has changed. So that is one number that's been projected. I've seen as low as 1.8 to 1.9, 0 to 60 with the Model S, which is extremely fast for a four-door sedan, mind you. This is not considered a quote-unquote coupe or sports car. This is a four-door sedan making those numbers. So anybody that says, are electric vehicles that fast? I would encourage anyone to sit inside of a Tesla Model S and see what that feels like. And it's not that lower models are not, it's just a different experience. They're the upper tier, upper crust of electric vehicles, okay? So a term that gets thrown around a lot is, I need electric vehicles have a charger, okay? The actual technical name, and I didn't make this up, excuse me, it's the industry that made this standard, is called the Electric Vehicle Service Equipment, or an EVSE. And the reason why it's called an EVSE and not just a car charger is because not only is it providing electricity to the vehicle from the point of whether it be a wall socket or level 1, level 2, 220 volt, but it's actually communicating with that electric vehicle. So it's doing more than just charging. It's actually talking to the software and the modules on board to say, what is the current state of charge? What is the current temperature of the battery pack? Those are communication factors that are going back and forth between the piece you plug into the wall and the vehicle itself. That makes sense? So there's a lot more involved than just charging the vehicle. And it is as simple as charging a vehicle. That's the balance that we see in the electric world. When we plug in our vehicle, we think we're just charging the vehicle. There's a lot more going on there between just simply charging the vehicle. So that's why they give it a broader name, Electric Vehicle Service Equipment. Now, starting on the left to right, on the left-hand side, all electric vehicles, especially when they're new, come with at least a base 110, 120 volt charger. And you can see the plug type right next to it. That makes sense? So anywhere in here where there's an outlet, I can literally plug my car in and charge it. Now, as you can imagine, with the lower voltage and lower amperage, it's going to take a while to charge that car. That makes sense? Because things in here that we plug into the wall require less electricity to run them anyways. This computer, this projector, all require less. So when you try to plug that in, your electric vehicle into that, it's going to take longer to do that. On average, my personal experience, if I've dropped my car to, say, 10% of electric charge that's remaining, it takes about 20 hours to get a charge. Now, people are like, my gosh, that's a lot. Well, consider this. That's level 1. When we move to level 2, which is in the center picture, now we're starting to look at the electrical code of what's called the NEMA 1450 plug. Most of you are familiar with that with a plug-in for a range, electric range in your house, or electric dryer. It's the same plug. So they share the same platform that's already out there. I can charge my car from about 10%, which I never go that low, 10% to full in about 3.5 hours. See, we're shortening that window, okay? That's level 2 charging. Level 3 are the 2 chargers you see at the bottom. And you can see all the charging standards there on your right. Level 1 and level 2 occupy the same plug-in regardless of what electric vehicle you have. So you can charge with the same plug-in interface, which I've brought some with me today, so we'll talk about those after we get done. You plug it into your level 1, it charges the same as the large level 2. That remains the same, makes it consistent, makes it easy. But when you start stepping into now level 3 charging, which is what's called DC fast charging or DCFC, that is 440 volts. So you can see we're going from 110, 220, we keep doubling, now 440. That's putting in a large amount of current in direct current form, not AC, into that battery pack. That makes sense? So my vehicle can go from about 10% to full charge in about 25 minutes. Now we've shortened that window from hours to minutes. Now it's important to know my vehicle's a 2016. And if you know anything about technology, anything that's in 2016 is probably considered antiquated. I only have a 30 kilowatt hour battery pack in my car, as compared to a Tesla, which has 90 and sometimes 100 kilowatt hours. See the difference there? So the larger the battery pack you have, the greater density of energy you can have, and you can travel further. That makes sense? My car travels about 120 miles per charge. I have different modes I can put mine in. I also have, which something the internal combustion engine cannot do, is what's called regenerative braking. So when I let off my accelerator, my motor now becomes a generator. It does the opposite and sends energy back to the battery pack through a management system. That makes sense? So it's nice because I can travel down hills and regain what I've lost. And I can actually see in real time on my dash how much energy is going back into my battery pack in percentage of charge, and also what I'm saving and gaining on range, extending my range. I can see those things in real time. And most internal combustion engines, you can see that too. You can see what your range is still left, but you don't see the regenerative part because it simply can't regenerate that way.
Question.
Sure.
Could they put something on the wheels to recharge the battery too?
You can, but you also know if you're looking to gain or match or parity to get all that back, the laws of thermodynamics will always say we can only take energy from one point to another. You're never going to gain all that back.
You can only
You can do that though. Yeah, and people have actually done that.
The prices of this challenge.
Exactly right. Had a generator settle, yes, and it works the same way. So I do that through the storage medium. That's used in real time because you didn't have a battery in most cases there. You had it running, like you said, a light or a tail light.
Right.
So it's the same principle. In my the faster you went, the brighter the light would get. Exactly. In my case, when I go down the hill or something off the accelerator, it also regenerates my backpack or battery pack. Same purpose. What's also nice, when you look at regenerative braking, you're also using less brake power because that has to go through the electric motor and it functions as a brake. So it's an electric brake. So brake pads in my car, and I'm obviously involved with Nissan groups online. Some guys have over 100,000 miles. They've never replaced brake pads because their electric motor does the majority of their stopping, except for the last moment. When it comes like a stoplight or a stop sign, you still have to apply the brakes in most cases. So they call it regenerative braking. And there's also what's called one pedal braking. So some of the more advanced EVs that are out now, some people don't even brake when it comes to a stop sign. It's that they get so accustomed to the car just stopping for them, the electric motor doing all that, they don't even usually hit the brake unless it was a panic stop. That makes sense? Now, just to broaden the scope out, we're not just talking about light duty trucks and cars that most of us drive. We're actually looking at larger commercial vehicles. As some of you know, Tesla has a Tesla Semi that they're attempting to build. They're testing on different gradients, different load types, different ranges. And most of us have seen the Amazon Prime trucks that are now being rolled out and developed, especially in California. Those are what are called last mile deliveries. And if you look statistically, where EVs right now can best benefit in the delivery sector, it's that last mile delivery. Some of you have even seen how the post office now is developing and buying fleets of postal vehicles that are all electric because they are truly sometimes, in the words, the last mile of delivery. They're not going cross country. That work has already been done. And if that's even done by compressed natural gas or internal combustion engine, that's great. But when we get to the last mile, the internal combustion engine is not needed as much because we can make those deliveries within the acceptable range of what this battery packs can provide on smaller delivery vehicles. We're also looking at heavy duty industries like the K580 EV fully electric backhoe, and then the front end loader that you see there on the left. Those are all electric vehicles that you see there on the screen. So what's interesting, you're going to probably end up seeing with multiple electric motor setups, especially on heavy duty equipment, because they can run the hydraulic systems, which are very efficient. You can't get past hydraulics very well. It's a wonderful system. So the PTO systems on those have been and will continue to be powered by electric going forward.
How many volts is what there's about?
Voltage, you're probably looking at over 250, 300 volts easily, especially the heavy duty equipment. What's nice about those is they don't have the long distance travel that our vehicles do, which really zap the electricity out of electric vehicles, long distance ranges. It's kind of the opposite with internal combustion engines because they're not as efficient in town. That's why hybrids were developed because where there were disadvantages in the internal combustion engine, hybrids came in to fill that void because we lose a lot of energy with the internal combustion engine from stop to start and from rapid acceleration. Well, if you have an electric motor that can cover those two areas, then we have the internal combustion engine for our long distance traveling on the interstate, where you can drop the RPM ratings down really low and have that engine almost sometimes at idle when you have 8, 9 speed automatic transaxles. They can really drop where traditionally 20 years ago, you'd be driving on the interstate, 2,500 RPMs in an automatic. Now those are sitting around 1,000 or almost sitting at idle, and you're traveling that quickly with higher speed gear ratios. Now remember, with electric vehicles, you don't have the transmission. So it has to have that higher RPM rating at all times. So you start to lose a fair amount of range on the interstate. Is it something to be alarmed about? To a degree. Depends on what size your battery pack is and how far away you are from an individual EVSEs, the charging infrastructure. But I think anybody in here can attest to, and I think we have someone here today, her son has a Tesla. Does anybody else here have an electric vehicle or a hybrid? Okay, so if you look at our vehicle registrations in the state of Ohio, you'll find that there's not very many electric vehicles. We're in the Rust Belt. We're in the Coal Belt. There's a large learning curve and resistance to what's going on. But if you look at a lot of the license plates on battery electric, especially Tesla vehicles, Georgia, Florida, New York, their infrastructure is really strong. And we can get into the specifics of it. Their V3 model superchargers, they can charge a car to 187 mile range in between 12 and 15 minutes. So you can travel from Wheeling almost to Columbus in 12 to 15 minutes. So people say, I still want my 5-minute fill up on my, that's fine. But let's look how long the internal combustion engine has had to mature and adopt. Over 120 years we've been dealing with the internal combustion engine. So I think we can give a little bit of squeeze to battery manufacturing and electric vehicles that have only really been in development heavily in the last 12 to 15. I think that's a fair comparison. So look how far we've come. We can actually charge electric vehicles on the Tesla model. 187 mile range. That's 250 to 300 kilowatts of power going into that battery pack in 10 to 15 minutes. That's astounding in 12 years. How long has the internal combustion engine had to do it? The only thing that saved the internal combustion engine is the fuel density. The gasoline or diesel has a lot of density in its fuel. If you look at the internal combustion engine by itself, 35% efficiency. If you look at the electric motors, 90% efficiency. So there's a seesaw effect to it, isn't there? The electric motor is great in its efficiency. The internal combustion engine, not so much. It gives almost 60% of its efficiency away in heat. That's why everybody in this room who drives an internal combustion vehicle, they have heat inside their vehicle at wintertime. It's because the heat that's being taken off that through the cooling system ends up in your compartment through an heat exchanger, one through the radiator, one through the heater core. So with that loss of efficiency, now you can say the electric motor, how's it going to heat the interior? Because it's not as inefficient as the internal combustion engine. So there's a separate heater system outside of the electric motor because it can't produce, it doesn't waste like the internal combustion engine does. Remember, I'm picking on the internal combustion engine coming from and knowing that industry well. I've worked in the automotive aftermarket for on and off for the last 20, 25 years, including the recycling industry. So I saw a day-to-day process of what we were going through. And those things are part of and we can congratulate and thank the internal combustion engine up to this point. But it's starting to have a horizon now. We're starting to see a difference, a change that's going to be taking place. Now, this is kind of where I come in personally. We're not only talking about major manufacturers building electric vehicles. There's actually a website, if people want to go to, it's one of the more popular ones. It's called the EV Album. And there are people who have made homegrown electric vehicles themselves through lead acid, nickel cadmium, lithium ions now. They have actually produced their own electric vehicles at home. Do they have the range that some of the major manufacturers do? No. It's usually because they don't have the match parity of all the technology coming together. And let's face it, R&D and research and development teams at these major manufacturers, they have the time and the money and the resources to build it, to create that efficiency in the marketplace that we see. In the past, I'm currently working on a 1964 Jaguar MK10 to do electric conversion to. And the reason why I'm doing that is because once you look into the weeds of these things, the rear suspension on that car is the same as the Jaguar E-Type. So I didn't want the luxury and the beauty of a Jaguar E-Type or an XKE. I like the practicality of a sedan that you can take your family in. So the rear suspension is the same between the XKE and the Jaguar E-Type. There are developers now that sell kits that you can bolt, like we saw earlier, the entire drivetrain layout of the Tesla Model S into the rear suspension of a Jaguar E-Type or XKE. Well, now knowing that the suspension is the same as the Mark 10, we just introduced that into the sedan model. That's how that works. Where do you source these things? Where do you get batteries and motors that are on parity or actually from the manufacturers out there? If you go onto a website known as carpart.com, which is one of them, put a hyphen between car and part, you can look at an online database of salvage yards and recycling yards across the country and in Canada that have put their inventory online for you to look at. So you simply filter through. I'm looking for a 2017 Model S Tesla motor and drivetrain. And it will show you which salvage yards in this country and in Canada you can source those through, including batteries, including drive modules and everything else. So there's that whole recycling aspect and repurposing to go into some of the homegrown electric vehicles also. This is the big topic that's going on right now, especially the high heat that we've had in this country. California and Texas, two primary locations, right? Blackouts, problems we're seeing with the electrical grid. To be honest, we were having these problems before the electric vehicle came on board. We have an aging electrical infrastructure. No one doubts that. And thankfully, last fall, which we'll go into this more later, there was a bipartisan infrastructure bill that was passed. And as part of that, $5 billion of that goes into alternative fuel and electric vehicle development as far as EVSEs and charging infrastructure. But we need to, in just general terms, bring our electrical infrastructure back up. And this is where electric vehicles can be a part of that. Now, this diagram that I show here, it's kind of complicated to look at, but look at it this way. There's what's called common terminology that we're starting to see between engineers who are communication engineers, IT, and structural mechanical engineers. They need a common language they can talk about building up this infrastructure that we need as far as our electrical grid. And there's a term called IEEE 2035 that tells us these communication byways that engineers are working with now are trying to include our transportation into the electrical grid. That's something we really didn't do before, did we? When we go to a gas station, we fill up our gas tank and go on about our way. Unless you have an onboard generator or an inverter, you're not really giving any energy back to the electrical grid, are you? You're taking away from the gas pumps that provide that. Well, electric vehicles can be, and there's development software you can use, there's inverters you can use that allow that vehicle to be plugged into your electrical home outlets to be bi-directional. That makes sense? So let's say we have a high heat day in California. Air conditioners are running, which is the biggest, 40% of our energy use in this country comes from heating and cooling, 40%. So let's put petroleum aside for a second in transportation, of 40%. So the heating and cooling of our homes that are above grade in hot areas like Texas and California are going to be an instant demand to those systems. So if you introduce an electric vehicle, not only can they receive the energy from the electrical grid, they can also push it back out. That makes sense? So let's say you have a high peak demand in, say, 12:30 in the afternoon in California. Air conditioners are running off the charts. You can either do it yourself, or there's actually software that can bi-directionally take that energy from your car and put it back into your house to lighten the load of that overall energy grid. That makes sense? So you're not completely dependent on the power company bringing power to you. The power they've given to you that goes into your house, then goes into your transportation if you're using an electric vehicle, can now go back into the grid to even out that load over that amount of time until that level of demand comes down, which is usually in the evening. That makes sense? Things get colder, sun goes down, less stress on the grid system, and electric vehicles can then start charging back what they gave during those peak times. And people will say, well, what about electric vehicles? We're asking to introduce these to the electrical grid and we're having blackouts. It's important to remember, electric vehicles most often are charged overnight when demand is not as high. So when the sun goes down, when people come home from work, they're charging their vehicles at nighttime when there's less stress on the grid. And it's also important to note that those are home customers. They're being asked to conserve if they can. When you're out traveling on DC fast charges, you're also not at home and you're charging. And most people, I don't even charge until the evening. I hardly ever charge during the day. So it fits my lifestyle as well. I only charge at night. And there's also rates that utilities give people to induce, hey, you're going to pay less in your electricity costs per kilowatt hour if you charge only at nighttime, which it would be costing less to charge that vehicle as well. That makes sense? Now, outside of that, how can we make this practical? Well, one of the things I also like to do is I DJ. I like to DJ. So I've gone to locations multiple times and just used my car as the only electric source, providing all the power to my DJ equipment. So that cuts my costs down, cuts their costs down, which is not much. How many people honestly look at their electric bill and are shocked? Most people don't. Most people don't even know what they pay per kilowatt hour, but they sure know what they pay at the pump. See, that difference is coming into play. So just an example, natural gas furnaces between 700 to 800 watts, a flat screen television, which most people use, 150, chest freezer, smartphone, refrigerator. You can see the baseline of what those typically are. And then what you can use, and this is a picture of one of my friend's cars, he has a power inverter underneath his hood, and he has an Anderson electrical connector to his 12-volt battery. And then he can plug things into his car if there's a power outage. So it's more of a simplified version. Instead of plugging it in, he just does all of his work that way. So when we had a power outage, he knew exactly what all the output wattages were in his house of all the devices he needed. And then he streamlined that. I don't need some of these. I don't need that. I need a refrigerator. I would probably like to have a television, like to charge my phones, and maybe I have a chest freezer over there. And depending on what type of furnace you have, if it's a natural gas furnace, kind of meeting in the middle there, the only thing it really needs is the igniter and the blower motor to run the electronics for that furnace to work if it's in the middle of winter. Now, if you have a whole electric furnace, that's a little different story. But if you have a natural gas furnace, those are typically between 700 and 800 watts. He was able to run his house for about 3 to 4 days without having to charge his Nissan Leaf. He has a 62 kilowatt hour battery pack. So it's essentially double what I have. And obviously mine would be less than that because I have half of his capacity. So when you have a power outage, and this is not something unique to the electric vehicle, internal combustion engines can do this too, but they're also going to be running gasoline in order to maintain a 12-volt battery. Those things have to take place also. But electric vehicles allow that advantage also. Some of you have probably seen the Ford Lightning pickup that has the integrated power inverter. And I want to say it's at least 10 kilo, I want to say around 10, I may be too high on my figure, 10 kilo, but it also has the ability to charge other electric vehicles. So it can be piggyback and do those characteristics as well. This is something that's often forgotten. You know, electric vehicles eliminate over 24 mechanical, including maintenance components, in comparison to the internal combustion engine. So you lose the engine oil and filter, don't you? There's no reason for exhaust anymore, so the exhaust system is gone. If you ever worked on exhaust systems, you don't really want to. They're not fun, like brake systems. You lose the V-belt, if certain vehicles still use that, serpentine, balance shaft, timing chains, belts and components. Engine air filter, you still have a cabin air filter in most electric vehicles. But perhaps most importantly, you lose, besides the oil, you lose the complete secondary ignition system. There's no spark plugs. There's no ignition wires. There's no distributor if you still have a car that has a distributor. There's no electronic ignitions. Those are all gone now. They are replaced with certain solid state management systems, but you don't have those individual parts you have to replace every so many miles. And that, to be fair, the internal combustion engine, that timeline has been built out. Some of you are here old enough to know that you would have to change points and plugs maybe every 20, 30,000 miles. That got extended to maybe 100, 150 miles when you would start changing spark plugs. So that timeline has changed, but the overall cost and maintenance of that are completely gone with the electric vehicle because everything is concise to that electric motor. It's doing all that work for you. This is something that's important. It's your tax dollars. So I think most people are in agreement with this idea, or at least now know where their money is going. So the NEVI, it's called the National Electric Vehicle Infrastructure Program. Some of you know the Eisenhower Interstate Program, and it's done the same way. The NEVI formula provides funding to states to strategically deploy electric vehicle charging infrastructure and to interconnect networks to facilitate data collection and reliability with access. That makes sense? So people are saying they're just throwing money at these electric vehicles. No, there's actually criteria built into this program. Is there going to be waste? Every government program has waste. We all waste. Government can do it on a large scale too, but let's look at what the ingredients are. It was funded, like we said earlier, by the bipartisan infrastructure bill that provides $5 billion in funds, $1 billion each year until 2026. That's how that's broken down, okay? Now, there's still rate negotiations going on for kilowatt hour time and ongoing utilities like AEP, Duke, whoever provides your electric energy, and the EVSE owners and operators. So people who own and decide to put electric vehicle infrastructure on their locations, a gas station, at home, on the interstate programs, those negotiations are going on between a time and kilowatt hour usage rate. Those are still ongoing negotiations. Now, in Ohio, how many people are from Ohio in here? I am as well. So we have several people from Ohio. In Ohio, the Ohio Department of Natural Resources have actually gone ahead and used some of the early funding to establish, logically they should go in here too, some of the national parks that are in the state of Ohio. So you can do electric charging, which are usually more remote areas. People always say, well, I can't go to a national park in any state and get my vehicle charged. Ohio said, well, you have a better chance of doing it now because we put those charging stations, especially at level 2, not level 1, but level 2. And I've had several friends who go camping with their electric vehicle, and there's usually a level 2 charger as a part of your electrical infrastructure there for your camper. So they're charging right there. So I think what a lot of people miss about this national electric vehicle infrastructure idea is I don't see these infrastructure everywhere. It's literally in this room, if you think about it. Any place there's a 110 outlet, although it may be slow charging your vehicle, that is right there. We're not digging up the ground and putting tanks in and putting liquid fuel into it to pump it with electricity into our vehicles. Our electrical infrastructure is vast in this country, outdated in some sense, but it's vast. So I work here at West Virginia Northern Community College. I can literally charge my car there with an outside 110 outlet while I'm sitting at work. I've done it in Weirton. So when I travel from my home in St. Clairsville to Weirton, to the location, I plug in outside. I don't need a liquid fueling station down the street at Sunoco, BP, you name them, Sheets. I don't have to worry about that because it's right there in front of me. That's how convenient it can be. So going forward with that, the state of Ohio is an excellent example of how far the state of Ohio is ahead of other states. So here's a state-specific example. Allotted to the Ohio Department of Transportation, that's where the money is going to be coming in. And the guidelines of how the state was going to use this money, those had to be in by August 1st. So by August 1st is the time that the build-out has to be laid out. And then by November, this money is going to be going out to the individual states. So $140 million for Ohio over the next 5 years is what that breaks down to. Now, after that, it becomes discretionary once alternative fuel corridors, which the state of Ohio has 15. Most people don't even know what alternative fuel corridors are. But we actually have 15 in the state of Ohio. Now, when we say alternative fuel corridors, what we're saying is, in the last 25, 30 years, as the focus of transportation has switched, maybe not to electricity, but in biofuels, compressed natural gas, we build out infrastructure in place of that. We have 15 established in the state of Ohio. So our federal government and researchers said, why don't we just put our existing electrical infrastructure that we're building out here for electric vehicles, why don't we put this within the existing alternative fuel corridors? We're talking about alternative fuels besides petroleum. Let's build those within that. And then we interconnect those between other states' alternative fuel corridors. So we have a large build out. We're building essentially internal electrical grid between state to state that way. So you can see by the battery locations here, those are the 15 that are in place. Now, as part of that money being released, as a part of the criteria, each state has to find out in their existing infrastructure, where do they have, and this is the criteria that we'll go over here in a little bit, I'll give you a push out of it. Each build out has to have at least 150 kilowatts, each charging station or EVSE. There has to be 4 of those, and they can't be any more than 1 mile away from an interstate interchange. That makes sense? So think back in your mind when you're traveling on the interstate and you're looking for a gas station and you see, yes, there's a Sunoco, there's a BP coming up, they get off. And when you get toward the end, it usually gives you the distance, doesn't it? Of how far away you are from that select. The same thing has to be built into the convenience of electric vehicles. So that charging station will be identified. It can't be any further than that. Now, as you can imagine, the existing infrastructure that we have for people like me who are driving electric vehicles, they had to look at their existing portfolio. Like, where are these things already at? Let's not waste all this money. Where are these things already at that already meet these requirements? At least 150 kilowatt hours or 150 kilowatts. Have to have at least 4 of them. Have to be no more than 1 mile from the interstate interchange. That makes sense? Then we can fill in those places that are not available yet, that don't meet those criteria. So for example, if I was to travel from my home in St. Clairsville to Columbus, Ohio, and we'll get into this in more detail here in a little bit. If I was to travel that far, the first place would be, for me, for level 3 charging now, that's 150 kilowatts. I can stop in Cambridge, Ohio, and there's a level 3 of Electrify America charging stations at that Walmart in their parking lot, and there's 4 of them. Now, my car has an older, kind of antiquated standard for level 3. It's called CHAdeMO. Don't worry about the name of it. It's called CHAdeMO. The new is called CCS. It's combined, and the manufacturers are going that direction. Even people who've been long stays at that Japanese standard of Chatham, they're going to a unified standard to make it more universal for people to pull away to charge.
You have to pay somewhere to get that charger, right?
Not always. And there's mechanisms built into that. And I'll give you a good example. Level 2 charger, Tanger outlets in Washington, Pennsylvania. Does everybody know where that's? It's on Racetrack Road. If you go up there, there is a company called Volta. And they have these, as a part of their EVSEs, they have these giant LCD screens that they use for advertising. So their mechanism of making money to pay for the electricity going into your car, which is free, is to sell advertising on that board. Try doing that in Detroit. You don't have the same advantage of that.
Well, the government will start charging something.
Well, there's going to be, and here's where the taxation comes into that. I pay $200 a year for my registration in the state of Ohio. Why? Because I'm using the same infrastructure that everybody else is using with their internal combustion engine to pay for the road tax that I'm not being charged each time I pump at the pump. That makes sense? People say, you guys are the scapegoat. You got, no, I pay $200 a year for my rent. People say, oh my gosh, it's expensive. Go ahead and fill up your fuel tank and see how much you pay of that in tax. And combine that every time you fill up during that year. It's going to be over $200 in most cases.
How long does it take you to charge your car since it is a 216? When you go there to charge it?
The majority of the, let's start with the majority of the time when I charge at home. So I very seldom charge outside of my home. And I very seldom, in all the travel that I do, I charge, like I say, 80 to 90, maybe 90 to 95% at home. So I know exactly how much I'm paying per kilowatt hour, which is 11 cents to charge my car. And there's a slide on here that gives you a direct comparison between what you pay in fuel and the current mileage MPG of a gasoline engine, which I'm going to pick on my wife here in a little bit. She doesn't know about it. She drives a 2020 Dodge Durango that gets an average of 23 miles per gallon with a V6. So we'll talk about that here in a little bit. And I think that'll further answer your question. You'll see how much I pay to fill up my car on average. I can tell you right now, I pay between $20 or $30 to $35 a month to run my car Monday through Friday. I average about 66 miles a day on my car. I don't stay at home and scared about range. I go out with my sons on the weekends. We go to Pittsburgh, we go to Cleveland, and I use that existing infrastructure with a car that's now a 2016 with a 30 kilowatt hour battery pack. So you can do a lot with less if you really look at it and you plan.
How many hours then? When you plug it in,
Yes.
how long does it take for the charge?
At the outlets you see in here, the 110, it would take from about 10% to full about 20 to 20 hours. Okay. At level 2, which is 220 volts, 4.5 hours. At level 3, 25 to 28 minutes. I'll give you an example of that. We talked about going to Cleveland, right? I took a nice scenic route from my home in St. Clairsville, went up through Tappan, went up through Uricksville, New Philly, hit 77 North, ended up in Canton, Ohio. I charged at a level 3 charger there at the Dunkin' Donuts of all places. And you'd be surprised where you'll find level 3 chargers at Dunkin' Donuts, all right? They know it's a destination. You're going to go there and spend time or money, right? So I pulled into Dunkin' Donuts, plugged my car in. By the time we got done drinking hot coffee or hot chocolate and donuts, my car was fully charged. We went on to Cleveland. And with the rock, no, I paid at that EVgo, I paid $2.75 to charge. Right. Now, that's not meaning that those mechanisms are the same across the board. Remember we talked about how there's negotiations between kilowatt hours and what people are going to pay. Sometimes you pay a flat fee no matter how long you're there. Sometimes you pay per kilowatt hour like you would at home. Now, obviously, it's going to be more money. I pay 11 cents at home. But when you get out on the road, sometimes you can pay $50, $80 per kilowatt hour because you're paying for that infrastructure and the cost of them doing business to have that EVSE there. That makes sense? And remember, unlike the petroleum internal combustion engine, I can produce all my energy if I want to through renewables. The internal combustion engine cannot do that by its very design alone. So if I wanted to go completely off the grid and charge my vehicle with the sun, the wind, and the tides, I can do that. You can't do that with a petroleum engine. You can bleed in different fuel types in a sense with ethanol, biofuel, biodiesel, which I used to do biodiesel too. So I'm not completely separated from that world. There's mechanisms, but there's two things you always have to remember about infrastructure and how it's laid out. Is it profitable and is it scalable? Can we meet as many needs as people as we can, and can we make it profitable? It's unfortunate that the profit piece comes into it, but that's how our capitalist system works. People have to make money in things they do. That's how the world works right now, right? But there are other mechanisms for people to make money. Through the advertising like Volta, I charge up there and charge for free when I go to the Tanger outlets. It works well. So charging infrastructure installed every 50 miles like we talked about. Why is that important? And I'm glad they built this into it. For people like me that have low kilowatt hour battery vehicles, and you often hear, I can't afford an electric vehicle because they're over $60,000. I paid $12,500 for my car back in 2019 under the last administration. So you can leave politics aside. The marketplace can really have an advantage if you want to. Leave Donald Trump aside. Leave Biden aside. I bought my car when Donald Trump was president. He didn't say to me, no, can't do that. He may have executive branch and maybe some influence to make things change, but I was still able to buy a vehicle underneath that presidency. I didn't buy it to scramble it. You got to think ahead, you got to plan ahead a little bit. So I bought it just outside of Columbus, Ohio, in Grove City. Drove it home, not a problem. Stopped at my first level 2 charger on the way home just to see how it worked in Cambridge, and drove on to St. Clair's. It's an amazing feature. So, this is a review. At least 50 kilowatt hours have to be a part of this, no more than 50 miles away. So for people like me that have a lower kilowatt hour battery, I can meet that range. That makes sense? And it opens up the secondary market. So for people who say, I can't afford an electric vehicle, have you looked at the secondary market? Have you looked at the Chevrolet Bolt that now has lowered its price below the Nissan Leaf and has an average range of 260 miles to charge? So the arguments are starting to dwindle down very quickly. I'm not brand loyal by any means. My electric vehicle next will probably be, and I'll keep mine till the wheels fall off of it most likely, will probably be a Chevy Bolt. That's B-O-L-T, not the Volt. They discontinued the Volt, which is a semi-hybrid. But 250 mile range, 260 mile range. Depends on how you drive it, depends on other conditions. And it's under $26,000 new. And that's before tax incentives. Now, to be fair, the tax incentives have gone away, we'll talk about later, for General Motors, because they bought up over 200, people have bought over 200,000 electric vehicles from GM as a brand. So that's where that cutoff is at. As a part of that criteria, this is something I think we have a real opportunity to do that we didn't consider necessarily in the last century. Think about all the labor strikes that we had, United Auto Workers. Think about all the strife that we had about where petroleum was going to be pulled from, where factory pollution would come from. We sometimes put those in areas where we consider environmental justice, in areas where low economic people live, people of minorities. We stuff plants in these places, and we'll build cars here, and we'll extract the minerals from this place. Those things traditionally have been done that way, haven't they? So we now have an opportunity now going forward to say, yes, we're going to still have some ecological, environmental footprint to be concerned about, which we'll talk about. But we have an opportunity now to have other people engage, other shareholders, meaning public agencies. Contracting has to come into this. Civil rights. Where does civil rights fit in the other? It fits right in. I mean, you're paying people to do important work to build our electrical infrastructure and our EV infrastructure, and you're not going to pay them, based on their ethnicity or their gender. They have an opportunity to do all this stuff. They can build cars like the rest of us can. So those things are now. Cybersecurity has to be built in that. That's a big thing. Natural infrastructure also includes our defense systems. So by not meddling in foreign affairs where oil and petroleum deposits are, we have a real opportunity to bring a majority of that into our own country. So we can build our own infrastructure out. We don't need your petroleum over there anymore. We can produce the majority of our work through existing legacy coal, natural gas, but we now can add into our portfolio renewables, which you can't take from us. It's a big difference. How's the lithium battery going to be a part of this? Remember, we're currently talking about lithium batteries, right? So if you look at, we have to mine and extract. So if you look at this chart, and I'll go through this, there's a lot of information here, but look at the flow chart real quick. We extract these things, right? Through either rock mining or coal mining. That's where lithium comes from. It comes from the earth. Some debate is whether it's rare earth. Some debate is whether it's just earth minerals, okay? But lithium is actually a pretty abundant metal. But there are other parts of that makeup that are not as abundant, like cobalt. So what manufacturers are starting to do now, they're so ahead of the game, they're starting to extract some of those pieces that they originally thought were needed as a part of the battery makeup, like cobalt, and leaving those out. So now we're down to 2 or 3 major metals inside that battery pack instead of 4 to 5. That makes sense? So it's changing as things, it's morphing and it's changing as it's going on. So we look at the extraction, then we have to go through a material process of putting those into cells. And then here's something the internal combustion can't do is recycle those back into the supply chain. There are companies like Li-Cycle that was once a Canadian company, now it has infrastructure here. They started with a chemical process to take old lithium batteries from battery packs of electric vehicles and strip that out. They first did it chemically, but now they're starting to do it mechanically. Because once you start to get into the chemistry of acid baths, that becomes ecologically, environmentally unsafe, as you can imagine. But now they do it mechanically, shred it. And they extract those minerals out, and they have a process now where they can take out between 80 and 90% of the lithium from old batteries and put those back into the supply stream. So not only for electric vehicles, which is important, but something I didn't mention earlier with the electrical grid, you can have standalone batteries offsetting that electrical demand over time. Right now, California only uses 6% batteries to help its electrical grid get across that, what they call the gooseneck of electrical power. So when there's a demand coming from California, only 6% of that is battery. We can up that to help stabilize that grid, both in Texas and California, are good examples. So we have a closed loop ability to take old battery packs, and this is a common thing. What are you going to do with the battery packs when they go bad? Well, what do you think you do to things? We don't even recycle plastic and cups well enough. Let's look at batteries where it's even more important if we're going to use this for transportation. We have the ability now to do between 80 and 90% recycling back into the stream. It's amazing. And that is a secondary market. People are opening businesses just to recycle batteries. It opens up that secondary market. It hires people. It requires training. It requires benefits. It requires living room wages. All those things come into that. So how does this happen? Battery reclamation and repurposing. Toyota has it for a long time. They've used those as data storage and grid storage backup. So once, let's say, a Toyota Prius battery pack is no longer functional for traction purpose, they can take that battery out and put it as a standalone device to provide data backup for computers, or integrate it into the grid to balance out that load curve. Those are all parts of that. Nissan has what's called the Reborn Light system. They take Nissan Leaf batteries out and integrate those into lighting for streets. So during the day, they're capturing solar to charge that battery that's no longer usable in that Nissan Leaf because it's not functional for a traction battery. You can't go as far in that with that battery. And then when the night falls, a system sentry, when that dim goes down, it now pulls energy out of that battery and gives street lights ability to light your way. So there's uses for batteries is what I'm trying to say in the recycling side. Now, let's get to the very important piece, earth metals and environmental justice. No one who is honest at looking at electric vehicles can say that the process of extracting lithium at this time doesn't have environmental setbacks. It's true. I'm just being honest. I like the petroleum industry being honest on the same side, though. And then we can start comparing and whittling them down. So one example is Thacker Pass in Nevada. You know, Reno Sparks Indian Colony and other tribes are opposed to lithium extraction for EVs because they feel from a spiritual sense that those first tribe nations have their ancestors buried there. And if any type of disruption through a mining process of any type, coal, oil, natural gas, lithium batteries, that is an injustice they see, and rightly so. One advantage, though, to lithium extraction as opposed to other fossil fuels is you don't have to do it in one set location per se. And we'll get to that here in a little bit. There's less biological harm with lithium extraction based on a location where you can pull it from. That makes sense? So you may stand to lose a good bit of lithium buy-in or extraction from that area, but there are other places that are not as ecologically sensitive as that place, and you can pull those batteries out. And remember, what we're baking into this cake is the recycling factor of it too. So if you can recycle between 80 and 90% of what you take out of the earth anyways, that means less extraction from that point in the first place. That makes sense? Now, outside of the First Nations understanding, some of you also have probably heard the Democratic Republic of Congo, Congolese. And that's where you have, here's where in the Guardian article here, for me, the biggest takeaway is the separation between the major manufacturers and the subcontractors they use to distance themselves from responsibility of doing this correctly. That makes sense? So it's important to know that where we need to hold major manufacturers accountable is at the point of the manufacturer, not the subcontractor. They can get away from things that way, okay? Quickly, we talked about outside biological biomes where we can pull lithium from. There is Snow Lake, Manitoba in Canada that we're starting to do that from. It's also close, being in Canada. This is good comparative analysis between that and the tar sands and the XL pipeline everybody likes to talk about. How quickly you can get, and ecologically you can get that to the major manufacturers in the Detroit, Michigan area, where we know major automobiles in this country, the big three, are still in that area. And I'm trying to hurry through this. Once again, here's the recycling side of it. That gentleman you see there was a former employee with Tesla. He now is doing the recycling side to help the industry out as a whole. So I'm skimming through these. Transforming the Ohio Valley, how's that going to work? We talked about that, I promised that. Voltage Valley is what this area is being considered. This area stands essentially from the Lordstown area south through our Ohio Valley. We have several, like 4C Power, which is a French maker of EV batteries. They announced Monday when this was published, that's going to establish its U.S. headquarters in Hilliard, Ohio, creating 150 jobs. Sparks, which is a company that's removing the cobalt from the process, are doing solid state batteries in lower state West Virginia. And they've had signed agreements with the UMWA already. So that negotiating agreement is going on as we speak. We're starting to see the Voltage Valley build up. There could be a time when battery manufacturing and assembly could be done here in the Ohio Valley. We have a great natural resource, the river. We also need an advanced manufacturing hub to do the same. We could assemble bodies in the secondary market here. And most people know that the state of Ohio is the second largest supplier of the automotive industry. How many here have heard of the Ford 351 Cleveland engine? Where was that produced, as you can imagine? Cleveland, Ohio. We are the second largest. Outside of Detroit, Ohio is the second supplier of the automotive industry. Secondary components, engines, transmissions, suspension components, all those are built into that. We have the potential to do it here. We just have to get the blinders off and look at what we can do. Keep environmental consciousness in place and understanding economic feasibility. All those have to be built into that now. We can do that. We didn't really do that in the last century because we were building out our infrastructure so quickly during the first and second industrial revolution. This third and fourth industrial revolution, we have a chance to do it better than we did before. Fire concerns. Can't go without a conversation without fire concerns. The National Transportation Safety Board recommended to every manufacturer what they should do based on what they were seeing with automobile fires related to EVs, okay? And I'm not gonna read each one of these to you, but you can see the bullet points here. Fighting high variety voltage, they need to know specifically model-specific information. And there's even some first responders that say to me, we would like to know on each vehicle, if it's not gonna be in a centralized location, where is the disconnect for that high voltage system? That would be a benefit to us. Even you do that with an internal combustion engine also. First thing they do when there's a fire, they cut that electrical system off that 12-volt battery, where it could spark other problems with that gasoline that's in that vehicle. Now, if you go online, you'll see first responder videos of how they've maxed. There's actually secondary companies out there now that make vehicle jacks to lift the vehicle onto a 45-degree slant, and firefighters can fight and keep that lithium battery pack cool to suppress the fire. And it's amazing to see how that's developed. Some thought that it would be, we do a sweeping motion over the battery pack in a pattern that would do it. Firefighters said, no, here's what we found out. You do a spot. See, that's how we learn about the technology that we create. It's not always perfect, But we had a learning curve of how those things have to take place. We talked about the MSRP. People say, I can't afford a new electric vehicle. $60,000, that gets thrown around a lot. If you're gonna buy a Tesla, yeah, sure. But if you want a vehicle that gets about 259 miles of range with existing infrastructure and what's going to be built out, Chevrolet Bolt. I'm not promoting them. I'm just saying this is what the market has said. And that's what now the tax credit piece. Every manufacturer has a 200,000 vehicle capacity. So if you have a manufacturer that only says one electric vehicle is a part of their fleet, it's going to take them a long time to sell that one vehicle. But as EVs come on board, their fleet is going to gradually go even further into EVs. And that 200,000 will fall short as far as the tax incentive. How do you get that $7,500 money back at the cap? You have to have at least $7,500 in tax liability to make that happen. So you have to owe $7,500. I'm just being honest. And some people do. Like, man, I owe $7,500 in tax liability. If you buy an EV, that's where you get that money back. Make sense? Practical primer. Everybody likes practical news, don't they? How's this going to work for me every day? How am I going to do this? How am I going to travel from here to there? And what charging points do I use? I use what's called PlugShare. There's other apps on your phone or your laptop that you can look at what existing infrastructure is out there. It's largely crowdsourced, but it's done pretty well. It's had some advancements to it. I want to travel from my house in the fall of February of 2021. My son had a Taekwondo tournament that we had to go to in Bolivar, Ohio. Some people know where that's at. It's above New Philly. And I was a little concerned because one of the things that EVs do have is in colder temperatures, the range tends to fall off a little bit. I lose about 5 to 10% range when it's cold. And when I say it's cold, it's pretty cold. Like, I'll show you here an actual picture of my dash of what the outside temperature was, just so you can verify. So I plug in, just like you would Google Maps, my destination where I'm starting from, my home in St. Clairsville, to Bolivar, Ohio, where this Taekwondo establishment was. And I look through filtering what my charging requirements are in my car and how I want to charge. I can see where their charging locations are, just like you would look for gasoline stations along the way, which are more plentiful. I can see where I can charge that and what level they charge at. And I can also see, based on people who've charged there, how good was the experience for them? Was it terrible? Did it not work? Or did it work? Worked great? People were really nice where I charged for free. All those things are built into that. So you can see through these two screenshots, I was going to go to Parkway Nissan, which is on 77 North. I knew that after we did get done with Taekwondo, and at 9 o'clock we had to be at Taekwondo, my boys are going to be hungry. My wife is working the weekend. I took a chance and went to Bolivar High with my electric vehicle. You got to be a little adventurous too in this stage and game. Don't sit on the sidelines. Have a little fun. The people in this country are benefited. They'll help you no matter what. All right. So if you get in a jam, never run out of power in my vehicle. I've always been fine for the last 3.5 years of ownership. So put in the coordinates. Here's the charging location, Parkway Nissan. Well, their charging station is open 24 hours a day, so it's not just during business hours. So it's nice. And I called just to be sure to verify with the service people. Hey, you guys leave that on all night? He said, oh yeah, we leave it on all the time for customers. It's not just Nissan people come in here. We have other people come and get level 2 charging. And that's what we did. We set about that day. Here's your map system. From left to right, you can see Parkway Nissan has a rating of 10. That's the best you can get when people rate. You stay away from the 5s. There I am charging at the station on the way back. We ate at a Bob Evans before we came home, allowing the car to charge. My boys had some homework to do. We did that there. But you can see, if you can, upper left-hand corner, you can see I was going 50 miles per hour. But on the right-hand side, it was 14 degrees out. So I had temperature working against me, okay? We made it back. If I could advance the screen. Here's other things I've done with my vehicle also. Like I said, I DJ. There's the Volta. You can see my 2 young boys sitting next to the Volta level 2 charger that's free. They get their revenue from the advertising screen. I tow with my vehicle. I have a 5x8 utility trailer. And that on the back you see is actually a treadmill that I sourced. Because if you know anything about treadmills in wind energy, they actually have what are called permanent magnet motors, and they're excellent for windmill development. So you can build a windmill for your home. I'm not going to charge everything with it, but you can use a permanent magnet motor out of those. and they work really well. It was free. Somebody got rid of it. I took it home, put it on my trailer, and I built a windmill, electric windmill for it. So, and finally, here we go. Cost comparison, right? I travel about 66.6 miles a day, 65 miles per day on a weekend. My wife has a 2020 Dodge Durango, 23 and a half fuel mileage, $4. I conservatively went to $4, and that's about the national average now. It was higher, it's a little bit lower than that, but the average. She spends about $4,099 a year in fuel alone, okay? My car gets 4.5 miles per kilowatt. Some get higher, some get lower. That's pretty good for a Nissan Leaf. I pay 11 cents per kilowatt hour. I pay $589 a year, with a difference of $3,510 in difference in fuel costs. That could be going to building a solar system to power your car entirely. It could help pay that higher $60,000 test that you need. All those things are built into that. So I save that much money alone between our two vehicles. And that's it, guys. Any questions, comments?
My daughter has your Nissan.
Yes, right.
I think it's a 17.
Yes.
In San Francisco.
Mm-hmm.
And they do have a built-in electrical outlets.
At their home?
Yeah.
Yeah, I do too. I have a level 2 at my home, which is, I brought it with me here today. So if you want recommendations, don't get a level 2 charger that stays at your home, because you have the option to buy a portable one. So if you're at a friend's house and you need a little bit of charge, and they have an electric dryer that has the NEMA 1450 plug it in, and you now have level 2 at their house. Didn't require a fuel station, didn't require tanks underneath the ground. It's already established.
Perhaps obvious question,
Mhm.
terrain around here
Mhm.
as opposed to Columbus,
Yes.
Cincinnati, what does that do?
It does. It can have an effect. It almost has the same effect if you're traveling on the interstate for extended periods of time. I used to work, before I worked at West Virginia Northern Community College, at Straub Nissan up at the Highlands. So everybody knows 2 Mile Hill was pretty strenuous for any vehicle. Semi-trucks, internal, you're always going to use more energy, whether it's gasoline or electric. Towing a line, going up a steep incline. I lose about 10 to 15% if I go up that hill. But I have plenty I was never concerned going up that hill and say, oh my gosh, I don't have enough to get back to St. Clairsville, and I don't have enough to do anything in the evening with my family and my children. Never. I would go up the hill, come back down, and still come over to St. Clairsville and do things in the evening, go home and charge at night, see a full charge, and I leave the house in the morning. Not stopping at gas stations. That's all done overnight if you do it at home. That's right. It's a good question, though. And here's what's interesting. The dynamics that are built into these apps now, like the one I showed you, the plug share, it actually gives you, like you said, the elevation of what you're going through to take that into consideration. It's a good point.
I just wanted to know, your battery will last how long?
That's a good question. I'm glad you said that, because the first generation Nissan Leafs had some pretty bad problems with battery degradation. I'm not standing here and I can say that, okay? When they moved, the first Nissan Leafs had a 24 kilowatt hour battery pack. Its top range, 60 to 80 miles at the most, okay? 2016 hits, car looks pretty much the same, still what we call first generation, but a facelift in the automotive industry. It's now 30 kilowatt hours instead of 24. Greater capacity, greater range. Now I can go 107 to 120 miles instead of the 60 to 80. Nissan knew and admitted up to they had degradation problems with their batteries. Anything out the gate is going to have some problems, let's be honest. Even in the internal combustion engine world. Nissan said, we will replace your battery if you lose 4 of your degradation bars on your dash. You have a total of 12 when you first start out. If you lose 4 of those bars, and those all represent a certain state of health of that battery. And what's nice about Nissan, they're dishonest about it. They put the bars on the dash. You can see how healthy your battery is. Some manufacturers, you have to click through some menus to get to that. And even Nissan did that in their second generation Leaf. But my car is very honest. Man, I've lost 2 bars out of my 12. So 8 years. So 8 years is coming up. Mine's in 2016. So if I lose 2 more bars before the production date of 2024, Nissan will replace that battery pack, not with a 30 kilowatt hour battery pack, which is in my car, because they no longer make the 30. They'll upgrade it to a 40 for free. I bring my car to a Nissan dealership that has a certified mechanic. You do the paperwork, and they say 8 years, 100,000-mile warranty. If you drop 4 bars out of that 12 before the manufacture date of that 8th year, we'll replace your battery for free. And I'm not trying to hope for that, but I know that window's there because then my range would go to about 180 miles, which would be more practical. Right? It's good. That's a great question. I didn't even include that, so it's good.
Are there any all-wheel drive?
Yes. Well, Tesla has options for that, as you know. You're going to start to see that more in the, what they call the crossover SUVs and obviously the four-wheel drive trucks. The Ford Lightning pickup has that advantage. Ford Lightning pickup in its lowest trim has a range of about 300 miles, quad cab, for about a little under $40,000. So now we're starting to knock on the internal combustion engine's door real quick because people were spending sometimes over $60,000, $70,000 on a gasoline engine truck. And you can get an entry-level Ford pickup, quad cab, four-wheel drive, as you said. What you will start to see also, and this is a true complaint, towing capacity is not there yet, to be fair. Some people say you have to stop every 100 miles to charge, even with a 300-mile EPA range. So that is a problem. But how often do most people, let's be honest here, most people use a truck for towing every single day? They don't. Some do, and if you do, then you keep your internal combustion engine really anymore just for that purpose. That's how antiquated it's becoming. And it's hard for me to say that because I grew up in internal combustion age, that's the way it was. Anybody else?
Yes, sir. Getting these minerals, lithium,
Yes.
cobalt, and nickel.
Yes.
Are they all obtainable in our country?
Well,
Or do we have to go
right.
overseas to get them?
80% of it right now is being especially manufactured in Asia, in China especially. So that's a good point. We're looking at Chile is one of the pulling points. Also Australia. In this country, we talked about Thacker Valley in Nevada. But there's also that First Nation consideration we had to talk about, those native tribes who are living there. We've done enough damage to Native American tribes in this country. The last thing we want to do is continue to do that. So our best bet right now is that one in Canada, which, as you can imagine, the Canadian line is so close to Michigan, where a lot of that supply chain can be shrunk down. If we can extract the minerals on non-native land, constantly monitoring it environmentally, making sure the environmental progress is being maintained, and not to mention, look at the hydropower that they have in that area of Manitoba, Canada. So the majority of that energy would be hydro anyways, and they're trying to eliminate any petroleum-based trucks on that land. So all of our energy extraction should come from renewable sources at that site. And it's estimated 165, I believe it's 1,000 metric tons they can pull out of that. Not to mention what we can recycle back into that stream. Once you burn gasoline in your vehicle, where does it go? It doesn't recycle, it goes back out into the environment in a different form. At least with the batteries, you can recycle that up to an 80 to 90% effectiveness and put it back into those batteries. Anybody else? I think we're very over time probably. Good. Yes.
How much are these batteries?
That's a good question. My vehicle, and I was playing around with the computer one day at Straub Nissan. What would happen if my battery pack would go bad and I had to source it new from Nissan? To be fair, I had an employee discount built into that because I was an employee. I worked in the parts department last fall into this spring. My price was $2,500 to $3,000 for that battery pack. Now, that's a 30 kilowatt hour battery pack. So if you go higher, you can imagine those costs would be higher too. So that's why we as consumers really have to negotiate, force the marketplace to create that incentive. Like what's the average length of time is acceptable for most people for the major components of a vehicle to last? That's kind of your starting point. And then make sure the manufacturer holds to that through a warranty like we did with Nissan. Nissan said, okay, we tried the best we could with our first attempt at a mass production electric vehicle. We had some problems with it. Here's what we're going to do to replace it. That's where you hold the manufacturer accountable, regardless of who it is. General Motors, Ford, Chrysler, Tesla, you hold them to that standard. And they know that too, because that's brand loyalty, all that's built into them.
I have to say, you're a fine teacher. I'm sure you're a fine salesman. I came in here with zero information.